Okay. Good morning. All right. Today we're talking about properties of logarithms, which again, they're all very closely related to properties of exponents. And hopefully all these you know the answer to, but we'll go over them very quickly. What is the log of 1? 0. Why? Because b to the 0 equals 1. So again, yeah, if you give it a swirly, it makes perfect sense. And that's, again, if it's got a log in it, think about giving it a swirly, because that's how we figure things out in log form. Log base b of b is equal to 1. Why? Because b to the first equals b. Again, if you give it a swirly, that makes perfect sense. All right, but this one's a little more challenging. Log base b of b to the x equals x. Why? Yeah, again, if you give it a swirly, it makes perfect sense, because b to the x equals b to the x. So that's kind of useful. This one, log base e of x. There's something we can do. Log base e is the same as natural log. Ellen is a TV show. We don't talk about Ellen. Funny, yeah. So we say natural log, right? So that's natural log base e. And log base 10 is also one we have a shortcut for, which is just plain old log of x. So this is the common log. This is the natural log. And these are the ones that we like to use most often just because they're convenient and they're buttons on our calculator that work real nice. Okay. Now, today we're talking about properties of logarithms. And so we have some properties that we need to be fairly fluid with, because these are going to help us on Monday when we start solving more complicated log equations. We've done some good log equation solving using the one-to-one property. If your logs match, then so must the arguments. But it's not always going to be the case, and these properties of logarithms sort of help consolidate our equations so that we can apply some things we already know. So the first property is called the product property. The product property says if I have log base b of u times v, meaning I have a product multiplying two things inside the logarithm, I can actually add the logs. It means that we can expand log base b of the first thing plus log base b of the second thing. And so what we're doing today is we're actually using these properties in two different ways. Here we would say this is the expanded form. You can see that it's longer. We've written things out. We're using lots of logs. And over here is what we would say is the condensed form, where it's one single logarithm. Okay, and that's really important. This equal sign goes both directions. If you start here and you've got a couple of logs added together, then we can condense it down into a single log with product. Okay. So where does this come from? What's it related to? Well, it's related to exponent properties. If we have a product of exponents, 2 to the x times 2 to the y, these have the same base. What are we allowed to do? Add the exponents. So we get 2 to the x plus y. So we can add our exponents and we can add our logs. And so they're very closely related when we have a product with the same base, okay? They're all related to these exponent properties. All right, so the quotient property says if I have log base b of a quotient, so that'd be a division problem, u divided by v. I bet you all know this one. Subtract the logs. That's exactly right. So we can subtract log base b of the top minus log base b of the bottom thing. So log base b of u minus log base b of v. And again, same idea with exponents. If we had a division property, 2 to the x over 2 to the y, same thing. They have the same base, so we keep the base the same, and we would subtract the exponents, top minus bottom. All right, so very closely related. So we're allowed to add the logs, we're allowed to subtract the logs in a quotient. And the last property is the power property. Log base b of u to the power p. That's the condensed form. We are going to be using the product property all the time and the power property all the time. I barely ever use the quotient property because it turns out it's unnecessary. It's just a derivation of the product property, which I'll show you. The power property, this is the condensed form. The power property says that if you have a log and there's a power attached, then we are allowed to drop that power down in front and multiply it to our log. So we get p times log base b of u. And that's really nice for us because it allows us to make our equations a little more simple to solve. So I call that the power property, a power play. You get to drop your powers. The same goes the other direction. If you see a number in front of a log, you can also move it back up to its power position. And sometimes we need to do that, okay? So that number in front of a log can go in reverse and return to a power play, okay? Return to its power position. All right. So most of the time, we're going to use the product property and the power property. And the reason is, if you use the quotient property, you're going to make a lot of mistakes. So there aren't too many times that I'm going to be like, hey, guess what? I want you to do as little work as possible. The least amount of work, that's the path we want to take. Okay? So I'm going to show you how to do that. I'm going to show you how to do it quickly. So example 1, expand using properties of logarithms. So we're saying expand, and that is a literal thing, meaning we're going to have a log plus another log plus a log minus a log. Like there's just all sorts of logs all over the place. It's a big old mess. Oh, this is a tricky one. These are from U of A. I like to pull in anytime we can stuff that I had to do at U of A all the time. So expand using properties of logarithms. So rule number 1 with expanding using properties of logarithms is I want you to write the argument using exponents, always. Exponents, lots and lots of exponents. And it's actually a really good idea to get used to writing things with exponents. Because in calculus, we want exponents. We use exponents all the time, okay? So it's really important that you get used to writing things with exponents. And so what I mean by that is we have log base 5 of 10 times y, and this is times the cube root of z, in case you can't quite tell that that 3 is in the index there. So I'm going to rewrite this. This is log base 5. 10 happens to be a product. What is 10 a product of? What times what is 10? 2 times 5, yeah. So I can write that as a product. I can think about it as 2 to the first and 5 to the first. Then I have times my y. And this is the important part. You cannot have radicals. So I need to trade out that cube root of z and replace it using an exponent. That's going to be z to what power? 1/3. Very good. So now I've written everything as a product. And so what does the products property tell me I can do? Add up all the logs. Okay, the product property says that we can add all the logs. So we're going to do that. That's going to be log base 5 of the first thing plus log base 5 of the second thing plus log base 5 of the third thing plus log base 5 of the last thing. So log base 5 of 2 plus log base 5 of 5 plus log base 5 of y plus log base 5 of z to the 1/3. Lots of logs, okay? Really annoying. So then there's a few more things we can clean up. What are some things that you notice that we can still clean up? Log base 5 of 5 is what? 1. Okay. What else can we clean up? Log base 5 of z to the 1/3. This is a power here with a log in front. What can we do with our power? Where does it move? Does it move way to the head of the class? No, it moves in front of its own little log. So we're going to drop our powers for the last step. So we have log base 5 of 2 plus 1 plus log base 5 of y plus 1/2 log base 5 of z. Oh, sorry. Thank you, 1/3. Thank you. All right. This is fully expanded. Okay. Fully expanded. Why is log base 5 of 5 equal to 1? Because the swirly, that's fine. 5 to the first equals 5. So anytime you can simplify something like that, you're going to want to do that. Okay, so these properties of logs work with any base, and thereby this is also the same thing, log base e. We've just simplified it and used the natural log instead. So our properties work with natural logs as well. And what I want to do is I want to take this very complicated thing. I'm not going to use the quotient property, even though it looks like a quotient. I'm going to rewrite it using exponents. So I have x to the first times y to the third times. This is a divide by 3. But there's another way I can write that. I can think about it as a 1/3. 1/3 can also be written as 3 to the negative 1 power. Does that make sense to you? It's in the denominator. If I want to move it up, I can make a negative exponent. Okay? And so then e to the x, I can write as e to the negative x. So if you have anything in a denominator, you can simply move it up using negative exponents. And that is going to be really easy. And it also saves so much aggravation with the quotient property. So I will never use the quotient property. Never, ever. All right, so then I'm going to go ahead and expand all this. The natural log of x plus the natural log of the second thing plus the natural log of the third thing plus the natural log of the fourth thing. So that product property allows me to add up all the logs, the log of each thing. And then I can drop all my powers down in front. Now, if I've got a power of 1, that's not going to really change anything, but I can still drop it. All those powers are going to drop in front. What happens when those negative exponents drop in front? What happens to my positive? It becomes subtraction. That is why the quotient property is subtraction. Okay? It's just the product property. So we get 1 times the natural log of x plus 3 times the natural log of y plus negative 1 times the natural log of 3, or just negative natural log of 3. And here we have negative x times the natural log of e. Is there anything else we can clean up here? Natural log of e. What is the natural log of e? 1. Why? What is natural log? Log base e of e, and it's equal to 1 because, again, if you give it a swirly, e to the first equals e. It makes perfect sense, okay? So anytime you see natural log of e, it really is just 1, which is kind of nice. And so we have natural log of x plus 3 natural log y, whoops, minus natural log of 3, minus x. None of them on your worksheet are this complicated. But I do have an extra credit I just posted for you guys. There's some good stuff in there. It's good. All right, so these are expanding. You can see when we have that word expand, we're going to have lots of logs or added or subtracted together. I do want you to do that as quickly and as easily as you can. Like I said in your little worksheet today, it's pretty easy to do. But this was important because you'll notice anything with a negative exponent, you could condense backwards and it turns into going on the denominator. Positive exponent, numerator, negative exponent heads to the denominator. Because then what we're doing next is starting with expanded form and saying, hey, condense it to a single logarithm. All right, so here we go. Condense the expression to the logarithm of a single quantity, or rather a single logarithm. My favorite thing at the U of A was this test, which always happened like right after Thanksgiving break, which was a terrible time. But right after Thanksgiving break, and the directions are literally condensed to a single logarithm. Condense the expression to a single logarithm. And lo and behold, 2 of your choices, and it's a A, B, C, D, E multiple choice test at the U of A. 2 of the choices had a couple of logs in the answers. And people would always choose those. And you're like, wait a minute, didn't you even read the directions? There should only be a single logarithm. And yet you chose an answer with 2 logs. Okay. I was ready to leave U of A. I was just like talking to brick walls. It was horrible. Okay. So I have the natural log of 6x plus 1/2 natural log of x minus the natural log of 2x. The first thing we want to do here is move back any powers. The last thing we did was drop your powers, so we want to push them to exactly in reverse. Anything in front of a log, we're going to take and move back into its power position. So I have the natural log of 6x plus the natural log of x to the 1/2. And then, well, I suppose, what's in front of this natural log? A -1. We could move it if we wanted to. I'm not going to. Seems like more work. Okay. So as I said before, the quotient property isn't necessary. But when we condense, what we want to look for is anything that has a positive came from a numerator. Anything that has a negative came from the denominator. So we're going to condense this down into a single logarithm of a quotient, and then we just have to decide what goes on top and what goes on bottom. So the 6x has a positive in front. Does it go on the top or bottom? Top. The x to the 1/2 has a positive in front. Does it go on top or bottom? Top. You'll notice there's no more pluses. This is the product. Everything should be, there shouldn't be any pluses or minuses anymore. And then the 2x has a negative in front. So where does it go? The bottom. Top, top, bottom. And then if we can do any cleanup, then we want to do that. So I see an x on top and an x on bottom that can reduce. And also, what can I do with the 6 and the 2? Yeah, 2 goes into 2 once and 2 goes into 6 3 times. So we really get 3 x to the 1/2. 3 times x to the 1/2. You can leave it like that. That's a good answer. What is x to the 1/2? Square root of x. Yeah, that's another way you could write the answer. But I'm totally fine with this answer. All right, on letter B, you'll notice we have grouping symbols. Do not try to condense with grouping symbols. So I'm going to go ahead and distribute this 1/2 to the 2 terms first. So I have 1/2, oops, I keep writing natural log base 4 of x plus 1. And then I have 1/2 times -2. What's that? -1, yeah. -1 log base 4 of x minus 1. So get rid of those grouping symbols, and then we're going to move our powers. If there's a number in front, I'm going to move it right back up to a power position. Not going to worry about moving that -1. And again, this is stuff, a lot of it you can do in your head. Like I said, I really want you to do as little work as possible. No, it's not very often that I'll say that, but yes, as little work as possible. So like I can do all this in my head. I can go right to the answer. So now that I've put my power back up in its power position, I'm going to write my single logarithm of a quotient. And then we just have to decide what arguments go on top and what arguments go on the bottom. So this whole x plus 1 to the 1/2, top or bottom? Top. And again, because it's got a positive in front, it goes on top. So x plus 1 to the 1/2. And then the x minus 1 goes on the bottom. And again, because it has a negative, x minus 1. So this is a great answer. It's honestly my preferred answer. I don't know. But 1/2 means a square root. So you could write it with the radical as well. Okay. X minus 1. Thank you. Whew. That's a good thing it's Friday. All right. 2 mistakes in 1 lesson. That is solid. Okay. Do you guys have any questions for me? All right. Cool. Let me pass out your worksheet. 23 minutes. That's pretty long. Huh.